Okay, lesson 4. We're just going to continue our factoring processes and connect it to the roots, zeros, and x-intercepts some more. It's not really anything new. The first investigation, they're talking about something that would have been mentioned in Math 10C. See, this is a linear function. Do you guys agree? This is linear. So it's asking, okay, well, what's the zero? Find the zero. Well, it's popping out you right there, right? There's 3. So it's staring at you right in the face. So what happens when x is 3? Plug it into the equation. 2 times 3, take away 6. 6, take away 6. What are you getting there? Yeah, you get that the value of the function, when x is 6, you get y is... So when x is 6, y is 0. This is the x-intercept. That is, by definition, the x-intercept. When x is 6, or pardon me, when x is 3, my bad. Your confused look helped me understand what I did wrong. When x is 3, y is 0. Because we changed x to 3 right here. So thank you for that. So algebraically, while you're looking, if we look at the graph, it's easy to spot it. But algebraically, you want to set y to 0. And then you go 2x minus 6. Now, for linear equations, we talked a little bit about this yesterday. For linear equations, this is what you've been doing since junior high, maybe even elementary school. You're at Boston Pizza doing those little algebra things in the kids' book. But instead of putting x's, they put like boxes. Yeah. It's like block plus 7 equals 10. What's in that block? So yeah, that's where you got to put for these linear equations. You got to put the numbers on one side and the x's on the other, and then divide by the coefficient. So you put 6 on the other side. You guys okay with that? If it's negative 6 on the right, it's got to be a positive 6 on the left. Basically, just add 6 on both sides, and then divide by 2. And you get x being 3. Okay. So that's going to be the same for this one, because the x-intercept and the root is the same. They're just trying to show you, I'm not sure why, that these are all the same thing. So the root, the 0, and the x-intercept, they're all the same thing. Okay? You don't need to do any extra on there. They're all the same. Here, so at the top of the page, you can go like this. Roots, zeros, x-intercepts, all the same thing. They mean the exact same thing. If I say root, or say 0, or if I say x-intercept, I'm talking about the same thing. So this is more of the 20-2 style, where you have to deal with the quadratic. So staring at the graph, can you identify the x-intercepts? Here's one being 3, and here's one being negative 2. So x equals 3, x equals negative 2. These are the x-intercepts. So in order to do it algebraically, and you'll have to do this on my exam, so if you see this on my exam algebraically, that means you have to show your work. You can't use your calculator, because the calculator will give you this stuff for free, but on the written response you have to show it. So for this one, how do you solve this equation? Well, it's not linear. So it's not like the Boston Pizza style question, where you put the x's on one side and the numbers on the other. Because you can't divide by... what's going on? So we have to factor. You have to factor. Okay, so now we're in this question, because there's a 1 here that is not written, but you know it's there. What style of factoring is this? If there's a 1 there, it starts with an I, inspection. So which two numbers are going to multiply to -6? And which one's going to be negative so that you come up with a sum of -1? +2 and a -3, so that when you add them together, you get -1. Now solving these, though, you have to do the opposite. Recall that from yesterday. It's the opposite of what the binomial says. Okay, so these are the two solutions when you do it algebraically. They should match up with the graph down here. Right? It should match up. So factoring, connecting to the x-intercepts, by the end of today, hopefully you're a master of this. At the top of this page, what are the 4 styles of factoring you need? GCF, inspection, good, Maria, difference of squares, and one more, decomp. Those are the only 4. How do you know it's inspection? The A is 1. How do you know it's decomp? The A is not 1. For GCF, you got to look for like common factors. So that one's tough for people to spot, depending on like your number sense, like how good you are at spotting patterns or knowing numbers or having your times tables memorized. The GCF's hard for people that don't have, super strong number sense. But always check, okay, for the GCF, because it could be anywhere. Always check. Is there a common factor? And then the last but not the least, the difference of squares. What are you looking for difference of squares? What's up with the middle term? It's not there. So those are the 4 you got to get super good at. And that way, this last exam should be a cakewalk. Class example 1 at the bottom here? Or was that class example? Seemed to be already a class example 2. Okay, so this kind of terminology here, like let's just fill in the blanks and move on because it's really not that big of a deal. So the distinction, I don't think there's an apostrophe there. The distinction between these terminology, like it will not affect you. I am not going to grade you on your distinction between knowing that the zeros of the function, the x-intercepts of the graph, and the roots of the corresponding equation y equals 0 are the same numbers. I am not going to test you on that distinction. Okay? So the answers in these blocks are -2 and 3. And the y-intercept is, and you can connect the y-intercept, if you recall, to the constant of the general form. The constant of the general form, which is down here. And it's not the vertex in this case. So the y-intercept is not always the vertex. So just be mindful of that. So this next question wants you to use a calculator. We learned that last chapter, so I don't think anybody needs the assistance with that. Do you guys need assistance with that? How many have no idea how to find the x-intercepts on the calculator? Okay, because I don't think we need to waste time on it. Just, it's number 2, zeros. And if you don't know how to do that, I can help you today. So we'll just wait for... Okay, so for this question, hopefully you're just doing it right now on your own. Alright, so you type this in, you got to use the negative. No, it's not a negative. It's just 2x squared minus 7x plus a 3. Before you hit graph, I would just hit window. And then I would set the window to how they have it on the diagram. They only got negative 2 to the left, and then 5 to the right for the x-axis. And for the y-axis, they're going like negative 3 to 5. Alright, so you can see those x-intercepts right there. Second trace, number 2. And this is that left-bound, right-bound business. So if I know the x-intercepts roughly right here, you can't just guess with these values. You actually have to find the exact value. Whoops. So left-bound, go to the right of it, go past it, hit enter again. So it's 0.5. Okay, so hopefully you're okay with that one. So second trace, number 2. Go over to this one over here. And if, yeah, like hopefully you figured this stuff out last chapter, because you could use all this stuff last chapter. And you get 3. You guys good on that? All right. So one of them was 0.5 and the other one was 3. How about the y-intercept? What's the y-intercept? You just look at the equation in general form, so it's 3. So your equation should go through like this. And then how do you know where the vertex is going to be? Well, it's going to be about halfway between the 2 x-intercepts. Okay, so that's how you sketch it. The vertex is halfway between the 2 intercepts. Yeah. And then it goes through the y-intercept up here. Okay? So this one here, let's factor it. All right, let's factor this. So we need 2 numbers that multiply to 6, and we need 2 numbers that add to negative 7. So when they differ by 1, it's always when you have to times by 1. So it's going to be 6 and 1. Which ones are going to be negative, or both? Yeah, both. Good. Good, very nice. So when we write down the 4 terms, you have 2x squared, and the 7 is going to break down into, how's the 7 going to break down? Minus 6x minus x plus 3. What's going to come out of the first pair? Take out 2x, you get x minus 3. Now you see the x and the 3 on the second pair, but they're off by a sign, aren't they? Yeah, good. Pull out a negative. Excellent. And then you get positive x minus 3. So you get x minus 3 and 2x minus 1. So now connect those roots. Connect these factors to the roots. So obviously x minus 3 goes with the 3, right? That's obvious. So how does the 0.5 go with this? So you'd have to say, okay, how is 2x minus 1 equal to 0? Take the 1 to the other side and then divide by 2. So that's how you get the 0.5. Because those two factors have to be set to 0 and then solved for x. When the coefficient is a 1, like 1x take away 3, it's super easy. It's just the opposite of minus 3, which is plus 3. 3 take away 3 is 0. But for this one, and then what was my strategy that I told you guys yesterday? Cover up the 2. Cover up the 2. What's the answer? If the 2's not there, what would it be? Positive 1. And then divide out the... So positive 1, divide out the 2. All right. Determining zeros algebraically. This is the major idea of the unit. It's pretty much the whole thing. So if you get good at this, you'll have a strong mark for the final exam of the year, of the semester. Yeah, I'm thinking probably midweek, maybe like the Wednesday when we come back. Yeah. Well, we can decide probably at the end of this week. Okay. So let's do this. So determining zeros, the y has to be 0. So that means that the p of x, that's the polynomial function depending on x, this has to be set to 0. So then when you have two factors, when you multiply two things and get 0, what does that mean for these two things? 3x equals 0 or 4x minus 9 equals 0. That's that 0 product law. A times B equals 0. So this is that 0 product law. A times B equals 0. So when you multiply two things and get 0, A is 0 or B is 0. So in our case, A is the 3x, that's the first factor, and B, the second factor, is 4x minus 9. So for the first one, you divide by 3. What's 0 groups of 3? There's nothing in 3 groups. How much is in each group? Nothing. Good. Now this one, you throw the 9 to the other side with addition, and then you divide by 4. So again, with the second version, these ones, I recommend that you cover up the 4 like you can't see that 4. What would the answer be? And then divide by the 4. Sorry about my 9s looking like Q's. I don't know what I was thinking, really. So for the second one, this is the one thing that I have a hard time teaching because while I tell you to do it, or I can't like show you how to spot this. Like What do they have in common? A 5. So it makes sense to just bring the 5 outside. So they all get scaled down by 5. Now you only have to worry about what's in the bracket. The other thing is you make sure that 5 comes along for the ride the whole way. Now inside the bracket, what type of factoring is that? Say it. I heard it. Yeah. Why is it inspection? Yeah. Right here, big 1 right there. So then you open up 2 brackets. X goes here, X goes here, because how are you going to make 1x squared, right? Now how are you going to make 4? Is it going to be 2 and 2 or 4 and 1? So that you can get to a positive 3. You need to get to a positive 4 and then subtract off 1. So then the x-intercepts are x equals negative 4 and x equals positive 1. Is there an x-intercept from this? No. There's no x-intercept from that one. What's the maximum number of x-intercepts you could have? 2. So you'll never have more than 2 x-intercepts for a quadratic equation. Okay, second one, they just want you to find the roots and then the y-intercept. So for this one, what am I going to do with this one? Is the a value 1? So I got to use decomp. I need 2 special numbers that times to 30 and add to negative 11. 30 and 1? Nope. 15 and 2? Nope. 3 and 10? Nope. 5 and 6? And then you have to fist pump when you find it. So then these 2 numbers, you have to change the minus 11 into those 2 numbers. So are you going to put the 5 first or the 6 first? I would put the 6 first because it goes with 3. Excellent. And the 5 goes with 10. Does it matter? It doesn't matter, actually. It'll still work out. Yeah, it might look easier, yeah. So out of the first pair, what can you take? A 3 and an x. Good. When you divide 3x out of those first 2, what do you get? Now, how are you going to make the second pair look like x minus 2? Yes. Take out what kind of a 5? Negative 5. So you got a 3x minus 5 and a... Oh, that was beautiful. And the x minus 2. So, the 2 factors are x equals 2. That's the easy one. Hold on, don't say anything. Let someone else try. And this is what my recommendation. Cover up this 3 with your finger like it wasn't there. He's sick. Okay, so we have the 2 x-intercepts. Yay. Check that off. Do we have the y-intercept? It's 10. Lovely. Why is that y-intercept 10 when x is 0? Because algebra. Good. You put a 0 there, gone. You put a 0 for x there, gone. Y equals 10 when x is 0. So you have the two x-intercepts, and you get the y-intercept. That's it. Then I would ask that you guys start with number 5. Let's do 5 to 9. Let's see if we can do 5 to 9 in like the next 15 minutes, and then I feel like we should move on, because this is just a repeat of yesterday.